Hi, and to all those who've been following my Merchant Navy How-To series, welcome back. In this video, we are going to continue our celestial position fixing example by plotting our lines of position on a radar plotting sheet to obtain our actual position. Once I am back at sea, I will film the process of plotting on an actual paper chart, as I don't have a chart of the North Atlantic handy at the moment. If you haven't already watched parts 1 and 2, I would recommend watching them before you continue. So let's get started. The first step is to decide what time we're going to do our position fix for. Normally you would use the latest time you have a sight for, but there is nothing to stop you using the time of any of your sights. Having decided that we want the position for 20, 50 and 30 seconds, we start by plotting the intercept for Alkaid on our radar plotting sheet. As we have chosen 20, 50 and 30 seconds, we treat the crosshair in the centre of our plotting sheet as being the estimated position at this time, which is 33 degrees, 59.4 north and 045 degrees, 0.8 west. Firstly, before we do anything else, we need to decide upon a scale to use. You'd probably just use 1 centimetre as being equal to 1 nautical mile. However, because that will be so small on the plotting sheet and make it difficult for you to see, I am going to use a different scale. As it's quite difficult for me to do this accurately on the screen, I'm going to draw it by hand on a plotting sheet and I'll show you each stage as we go. From our calculations, we ascertained that Alkaid would be on a bearing of 313.4 degrees true, and we had an intercept value of 1.5 nautical miles. As the intercept value is positive, we say it is towards the true bearing of the celestial object. With that in mind, we draw a construction line from the centre of our plotting sheet for a distance of 1.5 nautical miles towards the bearing of 313.4 degrees, as shown here. Next, at the end point of this line, we draw another line perpendicular to it, which represents our position line at 20, 50 and 30 seconds. To follow traditional chart work symbology, we stick an arrow on each end of it. Our one line of position isn't much good to us. To get a fix, we need another position line to intercept it, but our time of taking the other two sites is different. To account for this, we need to transfer our lines of position, and there are a couple of methods of doing so. The method I am going to use, hopefully because it is the least confusing, is to redraw our origin point for each of the positions to take into account our course and speed. As we're working based on the latest position, and all our other sites were in the past, we need to transfer them forward in time. We were travelling at 10 knots on a course of 230 degrees. Therefore, in the time between our sight of Nunkey and 20, 50 and 30 seconds, we would have travelled 0.4 nautical miles. We need to transfer our position forward in time, so our new origin point will be 0.4 nautical miles ahead of our current origin point on our plotting sheet, as shown here with the red cross. Venus was sighted at 20:45. So when we do the same for it, we find that its origin point will be 0.9 nautical miles ahead of our 20, 50 and 30 second position, as shown by the blue cross. So let's plot our Nunkey position line. I will do this using a red pen so that it is hopefully easier for you to see. We do exactly as we did before, however you'll notice the intercept value for Nunkey was negative. Therefore we consider it to be away from the true bearing of the star. Essentially this means that rather than draw the construction line on a course of 190.9, we draw it on a course of 010.9 degrees. The distance remains the same, 1.1 nautical miles, and it will look similar to what is shown here. As before, we draw our position line perpendicular, and as it's a transferred position line, traditionally we indicate that with double arrows on each end. Assuming we were 100% accurate, and only using 2 lines, you could say that we're located at the intercept of these 2 lines. But since we need a third to cross-check, we'll continue and plot the position line for Venus. I've shown this in blue on the plot, and it will look similar to what is on your screen now. You'll notice that we have what appears to be a large cocked hat. However, please bear in mind that this is exasperated by the scale I am using, and the area within the triangle equates to less than half a nautical mile. If I redraw it using 1 nautical mile to 1 centimetre scale, you see it's actually a fairly tiny triangle. When doing celestial fixing, you're highly unlikely to not achieve a cocked hat. Even if your sight was 100% perfect and to the second, rounding errors introduced within our calculations, as well as errors drawing the fix on the chart or plotting sheet, will always result in a small triangle. Taking into account that we are mid-Atlantic, if we were to plot this directly onto our nautical chart, you would not see a triangle, as the scale of the chart is so small you can't be that accurate. Now as we have our fix on a plotting sheet, how do we equate that to a position? This is fairly easy. We simply measure off the difference in longitude and latitude from our estimated position to our fixed position. To do this, I'm going to use the 1 cm to 1 nautical mile scale and just select the centre of the triangle, which gives us a d lat of 1 nautical mile and a d long of 1.2 nautical miles. Because our fixed position and estimated position are only a few nautical miles apart, we can simply subtract or add the difference in longitude and latitude to get our actual position, which is 34 degrees, 0.4 minutes north, and 045 degrees, 02.0 minutes west. That's it for position fixing. As I said at the start, once I'm back on board I will film the process for fixing on a nautical chart, and post that when I am next back. I hope you found this video useful, and if you liked it, please hit like. To get notified when I post other how-to videos, don't forget to subscribe to my channel. Until next time, safe sailing.